Alright gang, so we're going to take and review today decimals with all operations. I know this is a little non-traditional, but with me being out, I'm going to try to be there for you as much as I can, so we're going to try it this way. We're going to look at word problems today with all four basic operations, beginning here with addition. So we're going to look at this word problem here. It says Taylor ran 23 and 8/10 miles in June and another 37 and 2,500 miles in July. How many miles did she run altogether in June and July? Now, first thing I want to do is I'm just going to kind of highlight or make sure I point out just some important information. I know this 23 and 8/10 miles in June and then 37 and 2,500 miles in July. It's going to be very important, but I need to know really the context within the word problem. What exactly is it asking me to do? So just, really try to conceptualize the problem in that Taylor ran a certain amount of miles in June, and then she ran a certain amount of miles in July, and the word problem is asking us to put them all together, and that's where our addition comes from. So now we kind of go back into the process, and with addition as well as with subtraction, the most important thing is that we set our problems up and that we're lining up by place value. So I write my first number down, which represents her miles in June. And then we're going to write down our July totals, but notice here I'm going to make sure that my tens are above my tens, my ones are above my ones, my decimals line up so that if I were to connect them with a line, that line runs straight up and down or straight north and south. And then I'm going to keep writing. And so when I do it this way, I notice that I'm kind of hanging off over here on the end. And I know that I can add a zero up here without adding anything to the value. So what I want to do now, once I'm lined up, I am lined up by place value. My hundreds are over my hundreds, my tenths are over my tenths, my ones are over my ones, and my tens are over my ones. I'm going to start at the very far right side and begin adding just really the top number and the bottom number. So 0 plus 5 is 5. 8 plus 2 is 10. I'm going to leave my 0, regroup 1. 1 plus 3 plus 7 is 11. Regroup another 1, and 1 plus 2 plus 3 is 6. Then I need to come back here and just get that decimal to be dropped right down. And what I know is that in the 2 months all together, she ran 61 and 500 miles. And again, I really want to make sure that I label those numbers because that's not just 61 and 500s, it's 61 and 500s miles. So there is an example of addition in terms of what you're going to see in a word problem setting as well as the process of how to add it. So let's back away and let's slide over here and take a look at another problem. This time we're going to take a look at subtraction. With subtraction, a lot of the rules are the same with addition in that how we set it up, that we want to line it up by place value, but we'll subtract instead of add. So we'll take a look at that in just a second. Let's first take a look at the word problem. It says Hagen bought a new UK shirt for $24.55 at the mall. If he gave the cashier $30, how much change would he get back? He must be buying the brand new shirt that says UK is better than Louisville because we have more national championships. When he buys this awesome shirt, we want to know how much money is he going to get back. Now let's take a look once again and identify some of the information that's really important. Now granted, I know you want to underline that because that's important, UK shirt, but we're going to hold off on that and we'll talk about the numbers here. So in the numbers, we know that he spent $24.55 on a shirt. He paid $30. And so now we're looking at like how much would he get back? How much change is he going to get back? And so you have to understand the situation. He's got this shirt. It has a value of $24.55. He gives the cashier $30. So what he's saying is, hey, what are you going to put back in my hand? He clearly overpaid. I want to know the difference. How much more did he overpay? So when we set this up, we want to make sure that we begin with our top number is going to be the greater number in this scenario. How much did I give the cashier? And that's $30. So I've got my 3 tens and my 0 ones. When I set up the shirt underneath it, I'm going to put my 2 tens, my 4 ones, and now I'm going to begin to kind of write this number out. Now I automatically notice that I've got not a problem, but just I can look at it, doesn't look exactly right because I've got this little area right here that almost looks like it should have some numbers, but there's nothing there. Well, one of the things we've talked about at length is that, I can add numbers as long as it's a zeros to the end of that, and I don't change the value of that 30. It is still, at the end of the day, 30 is the value. In this case, it's dollars, but I can add as many zeros to the right of that decimal place, and I will never add any value to that number. But in adding the zeros, it allows me now to subtract. So I've got a number now that is equally distributed on the top and bottom in terms of digits, and now it's time to do some subtracting. Then I hit another uh-oh moment. I look at this and I see all of these zeros, and my lone 3 is hanging out down here on the kind of on the end, and this guy down here really has to work its way into everywhere else in order for me to do any type of operation. So I've got to begin regrouping across all these zeros. So I'm going to start down here at my 30. I'm going to make this a 2, and then that becomes a 10. Now I'm going to, it's almost like dominoes. Make that a 9. This becomes a 10. Make this a 9, this becomes a 10, because ultimately, if I begin on the far right, I had to get that first 0 minus 5 to a number that I can actually subtract. So, here I am, 10 minus 5, 5, 9 minus 5, 4. I'm going to bring that decimal just straight down. It travels down in addition and subtraction. 9 minus 4 is 5, and that would blank itself out because 2 minus 2 is 0. So, how much change did Hagen get back? He would have gotten back $5.45 when he bought his UK t-shirt. So there's a look at subtraction with a word problem, as well as taking a look at the process. I will continue to stress with this particular skill is that when you regroup across those zeros, just keeping things in order. I cannot stress enough to get that grid paper out if you have problems keeping your numbers lined up from top to bottom, or north and south, however you want to say it. Get those numbers. Notice how my digits, every digit is in a box, and it's in that box by itself. But what that ensures is that I am straight up and straight down. Alright, now let's move on. We'll take a look at a multiplication problem. Well, let me get that in there. With the multiplication, the rules will change just a little bit in terms of how we handle the decimal. So we'll talk a little bit about that on the front end of the process. But before we get going, let's take a look at the scenario that we're kind of delivered here. It says Larissa bought a 5-pound pork loin to cook for her Super Bowl party. If the pork loin costs $2.75 per pound, how much did the pork loin cost? So what I have here is what multiplication tends to do. It gives me this unit cost. It gives me a unit, in this scenario, a cost, but some type of unit measurement. In this particular setting, it's for every one, it costs $2.75, but I don't have just one of those units. I have 5. So on one end, we could say it's repeated addition. I could go $2.75 plus $2.75 plus $2.75 plus $2.75 plus $2.75. But the beauty of multiplication that we've seen throughout the year is that I'm able to squeeze that massive operation there of repeated addition into multiplication by simply multiplying it by the number of times I wanted to add it. So with this particular problem, what we're looking at when we look at the information, we have this 5-pound pork loin that we know each pound costs $2.75. And ultimately, what the question is asking, well then, how much did the whole thing cost? If one costs $2.75, how much does 5 cost? So if I were to write this as an expression, it would be 5 times $2.75. So when I go to set it up, now I think it's important that I write this expression like this. Number one, it shows my really understanding of the problem. I understand that this is 5 of, because we see that we see our multiplication sign as of, but I know that that's 5 of 275. But it also allows me, when I rewrite this, to get rid of the decimals momentarily so that they don't confuse me. My next step is I'm going to rewrite this to say, well, this is 275 times 5. Because sometimes when I start plugging those decimals into this problem, it can become quite confusing. So as we talked about in an earlier video, and if you need a refresher, go check out my video on multiplying decimals, and that way you can understand why the decimal moves how it moves, instead of just knowing the strategy. It's very important to know that concept. But I'm okay that we rewrite this without the decimals, particularly if I take time to write out the expression. It's kind of, I'm showing up top, hey, I get what I'm doing, but when I do the math, I'm going to come down here to keep from confusing myself. I'm taking the decimals out. But now I'm going to go 5 times 5. And this multiplication, I'm comfortable with this. I know standard algorithm multiplication. 5 times 5 is 25. Regroup my 2. 7 times 5 is 35. Plus my 2 is 37. Regroup my 3. 2 times 5 is 10. Plus my 3, I come to 1,375. But that wasn't necessarily the case because I wasn't actually multiplying whole numbers there. Now I come back and adjust my answer. I come up top here and I count. There are 2 places behind that decimal point so that I can count 1, 2, and then place my decimal point here, which means that we paid $13.75 for the 5 pounds of pork loin. That's how we look at our multiplication, and that kind of helps me understand that I'm able to really multiply those whole numbers, and then on the back end come in and adjust my decimal. I really, really, really encourage you to leave the decimals out of the algorithm just to not confuse you. I don't want you to get caught up in thinking, well, the decimal comes straight down, or however it may be. We count the places. Again, I don't want to go into it now because I'm sure I'm going to go much longer than I carved out anyway, but I want to make sure that you have time to know this. So if you need to go watch it, go watch it. Otherwise, let's just focus on the strategy here. So here we go. Let's take a look now at dividing decimals. So last one, promise you. It says the word problem here is last week Edie ran 15 and 2600 miles. If she ran an equal amount of miles on each day of the 7 days last week, how many miles did she run per day? So this time we've got this large amount, and we are being asked to break it into equal. I love that. When you see equal amounts or equal groups, really that should start to cue you, going to be some division here. And then 7 days. Don't be fooled, because when I start scanning this, if you're a number fisher here, I love when we blend in these word form numbers, because it makes you really have to dig in and read the thing and not just look for 2 numbers and some keywords down here. So on this, we're looking at taking this 15 and 26, and we're going to divide it into 7 equal groups, because ultimately we want to know, hey, each day, how many miles did she run? So I set it up. We're going to take a look, and now is where we transition really from our big 7 that I know a lot of us are very comfortable with, but our standard algorithm, it really looks kind of similar. So I'm going to put my number that I'm breaking up on the inside, and I'm going to put how many groups here on the outside. Once I get here, then I'm going to start asking myself. My first question is, how many times will 7 go into 1? And it won't. 0. Now, sometimes we could put a little X up here. I know there are different strategies. Sometimes people put an X, saying it won't go there. This helps me keep my number lined up. Then I'm going to widen it and say, well, what about 15? Will 7 go into 15? Well, got to know your multiplication facts here. And 2 times 7 is 14, so it would go 2 times. So now it's 2 times 7 equals 14, which I'm writing that down here. And I'm going to find the difference here. So 15 minus the 14 is 1. I want to always stop here and make sure that this number right here is less than this number. Always important, because if it were greater, I didn't take enough groups out. But it's not. And then once I do that, I'm going to, didn't change my marker, then I'm going to drop the 2. And now I'm asking myself, how many times will 7, how many groups of 7 can I get out of 12? And 1, because I know last time 2 was 14, so it would be too many. 1, and 1 times 7 is 7. And I'm going to find the difference, and there's 5. Once again, I can check my two numbers. I need to be less than my divisor here, and I am. I feel good about that. Getting ready to run out of room, so I'm going to just slide down a little bit. Once again, I'm bringing down the 6. So how many groups of 7 will go into 56? Well, that would be 8. 8 times 7 is 56, which would actually leave me with 0. Now I'm going to go back. Once I'm at 0, I need to come down and bring my decimal point up so that I know that 7 groups we would come up with 2 and 1800ths. So the actual answer here is 2 and 1800ths miles is how many she'd run. So that's a good look at the standard algorithm. I will encourage you, we didn't see it with this problem, but just remember, if we were to have a decimal, for example, over here, that if we have to get this to a whole number, when I move it one place here, I would move it one place here. But again, there's a great video on division if you're still a little fuzzy on that. Otherwise, there are your 4 basic operations in the context of the word problem. I will be honest with you, my bigger emphasis right now is the word problem, just making sure that you're okay seeing these operations nestled into a story setting. So that's it for today. Sorry I'm not there with you guys. Hope to see you tomorrow. Got a sick one at home. Miss you guys. See you tomorrow, hopefully. Later, guys.